Hi folks, this is Adam Johnston, another video tutorial for the Cancha geometallurgy software. In this video we're going to discuss the Bonnie example. It's a fictitious example that we've made up of a small gold mine. So without further ado, I'll show you how to get it and how to use it and how it can be used to understand what the benefits are of using Cancha. So the first thing we're going to do is go to the webpage, cancha.pe. And here we've got under downloads, there's two things right now you can download. Is the latest version of the software, but in this case there's another download that's been added, which is the Bonnie example project data. And if you click on that, you'll download a zip file, and in that zip file you'll get this content here. Basically it's got some data files, the GMT file, which is the geomet file that can be opened within Cancha, some license information, basically the licenses that you have. Quite happy to use this example for anything you want to use it for, but please give it attribution, and if you can improve it, and if you add anything else to the Bonnie case, then please share it back with us. Always interested in having better information to share with people so they can understand and learn how to do geometallurgy. And unfortunately the lack of data is one of the things. The other thing in here is a PDF file, which is a Cancha Bonnie example. So let's just have a little bit of a look at that. We've got it's a PDF file, and basically it walks you through the exact steps that I'm going to be discussing with you today. So first of all, let's have a look at what the data is. The data, we've got a block model file, which is a CSV, a drill hole database, a metallurgical database, and a pit shell. These are the two just logos that you can use, which is an important part of this tutorial as well. So let's have a little look to see what's inside these files. Let's have a look first of all at the metallurgical database. So we've got the origin of the metallurgical samples, their head assays, and the results. So this is an Excel file. So as always, first row has got the heading, a single row at the top, which are all the column titles. And for origins, we always have to know what phase of test work it's from, what the sample ID is, what drill hole name samples were taken from and to interval for a metallurgical sample. In this case, head assays we're using as characteristics, so the assays for the metallurgical samples. And so here we've got the phase of each one, the sample ID, and then the assays that were done on each metallurgical sample. And of course the results, this is a gold project, so we've got cyanide consumption and gold recovery. Very simple. Again, phase and sample ID. So that's the metallurgical database. And we'll look at the drill holes. So in the drill holes we've got collars, and collars should always have the drill hole ID, the easting, northing, and RL, or if you want to X, Y, and Z, or easting, northing, and meters above sea level. Each drill hole. We don't have a survey file. If you had directional surveys, then you could use that as a separate database. But in the simple example, we've just assumed that the azimuth, the dip, and the depth of each hole is constant. So we've just added this table. If we had a surveyed one, then we'd have it, could potentially curve down depth. So there's the drill hole collars. We've got some blegs, which is like a bottle roll each to find out what the gold assay is. And they've got, for each drill hole, for different intervals, we've got actually gold grades, gold cyanidable grades in regular intervals, 2 meter intervals all the way down. But we also have some assays after digestion, and we've got gold and silver by fire assay and ICP scan. So lots of Nice information there on each sample. Okay, so that's the drilling database, and we've also got a block model, and the block model also has East, Northern, RL. You might notice that we've got different terms in each of these databases. It doesn't matter. Cancha, you'll see when you import the files, takes care of what the different names are, so don't be too stressed about that. The important thing is that you know that it's Easting, Northern, and RL, and that they're all in the same UTM coordinates for each of the different data types. Some assays, so we get some gold, silver, copper, arsenic, and sulfur assays per block. And we've also got some codes, which might be a resource category, for example, something to do with oxidations. That's maybe some sort of lithology domain or mineralization domain, and some in situ bulk densities that were taken for each block. So that's the block model. You might notice this was as a CSV file, so a comma delimited. You can still open it up in Excel, and you can still open it up in Cancha as well. So there's other tutorials on how to import data, so I won't go through that just now. What I will do is just jump straight into Cancha and show you that we've already imported it. We've set it up in project info. We've given the project name, the Bonnie Gold project. Client name is Taggart Mining. A little shout out to Taggart, who's a guru in mineral processing. I'm going to call it a preliminary economic assessment because we don't have that much information yet. Set it up with the client's logo and our Transmit logo. That just makes the reports look pretty later on. And we've got these imported. So we got these assays, the drilling data imported in from the Excel file. We've got the CSV block model imported, and then we've got all those metallurgical files as well. Oh, no, I didn't mention, but we've got a DXF file, which is a final pit shell, and so that's been imported as well. Okay, so we can click on any of these, we can see exactly where we've imported them from and what the file size was and file stamps and stuff like that. We can also go have a little look at the data that we've got in here. We can see, clicking on the block model, we can see what's inside each one. So you can say it's a bit better than the Excel file before, because here we can rapidly look for stuff that's got greater than 600 ppm of copper. We can see that very quickly. Or alternatively, we could say what if it's got a number 2 in the oxide code. Just add that there, and enter. We see all the rows, all the blocks in the block model that have a 2 in the code. So that's the sort of thing we can do in the tables. Now in the features, what have we got here? So we've got assays, for example, and what I did was I set up a ratio. So what I did, I just added a ratio here, and we've called the ratio of gold to silver, and then just drag these over, the gold and silver, and now I've got a ratio. I'll show you in a second what we can do with that. This was a mistake. You can see here that the boron should have been as a, it should have been a numerical value, but it was actually imported as a categorical, so a bit of a mistake there. We could do two things. I could remove the table from the database, or else I could hit this button here and change. So you can let's try that. So we just changed it now. Now it is numerical. So now we've got boron as numerical. Just want to check to see that the data is all good quality. So we go to shave the yak. Shave the yak is just finding out if the data's got any errors, getting the bugs out of it, shaving the long hair off the racehorse. But because the analysed data doesn't come back with anything, it means it must be good. Okay, so ready to rock and roll. So it's the assays. What else we got here? The blegs. So it's just one single feature. Here in the block model, that's to see what how the gold is. Well, you can see that it's being clustered. So you got the good ranges here for the clustering. But maybe we could do a bit better. So let's just make it a bit. Go from 0 to 0.5, 0.5 to 1. That's it's not going to leave us with a lot of samples in the top one. Let's go maybe 0.7 then. So we've got 3 ranges. It's most of the data is in this 0.5 to 0.7 range. That's good enough. But gold's not a very good colour to have green, so make it a nice golden colour. Make it gold. So apply that. And now we've got silver as gold. That's no good. I think silver is more of a sort of a blue colour. Let's go with blue. Apply that. And apply. So ready to rock and roll. Now we've got the colours set up. We've got that set up. Here in the oxides, so we've got oxides 1 and 2, and we've got transitional, and then there's fracturing stuff. Let's just group up the oxides, so we'll just group those together, and we'll just call this an oxide. We don't have to call it oxide 2. So we'll just call that, and apply that. Very good. We could use filters. We could go in here and add filters, but not a lot of data to start with, so don't want to take any out. Let's go ahead and have a look at it in 3D. So what have we got? Let's go through these things one by one. Let's take all the stuff off to start with, and we'll first of all we'll have the pit. You can see it's just a simple optimized pit from what do you call this? Like a Whittle type, a Lersch-Grossman type algorithm is run on this to give an optimum pit. We can turn that off like this, or we can just turn it on as a bit of a shadow there. Probably a better way to look at it so we can see what's inside. We could also change the color if we wanted, and that's fine. We could give it a brown color. Good enough. There's our final pit. Let's leave it like that. Let's bring in now the block model. So the block model, we've only got blocks that actually had reasonable values in them. We've already culled all of the waste blocks. What are we looking at just here? We're looking at the sulfur. So let's just bring up the gold. It's a gold project, so let's see where the gold is. This is very interesting. As you can see, it's a bit blocky from the outside. Let's use ISO values, and I'll use an ISO value of everything that is greater than 0.5. And using the colors like this, using these categorized colors, limits how much you can see. But if we go to this one here, we can start to see a bit more better detail. Right click on the legend, say show limits. So now we can see how these colors are. Let's bring up the legend here just so that it's easier to see, and we can see that at the surface of the Bonnie pit, and we've got these. Let's just make it a bit higher grade. Let's go up to the 0.7, and that way we'll only see the high grade. Maybe a bit more. Let's type it in there. 0.7. Okay, so where are we? Looking north. We can see that there's a big high grade in the middle. The gold, very good. Wonder what the sulfur's like. Oh, well, the sulfur's just on this side. Okay, so further to the where are we? Further to the west. So sulfur's on the west, and we've got some down here. Very nice. Okay, so let's just turn off the block model for the time being, and turn off that ISO thing, get rid of the block model. We'll bring in the drilling. So only 10 drill holes, not a lot of drilling. What are we looking at here? We're looking at sulfur. Sure enough, there in the west we've got the higher sulfur. Let's look at the gold. Sorry, that's the block model. Let's go up here to the assays. Look at the gold. Oh, we've got high gold in the west as well, where the sulfide was. That's no good. What else we got? I wonder how big this is. Let's measure it. Oh, yeah. 450 meters across. Very interesting. Get rid of that. So let's bring in the samples. where are my metallurgical samples? This one here. And you can see that right now we're colouring these from low recovery of 16 to 32 up to high recovery 70 to 95. But really, anything less than 80% recovery is already bad. So let's do something about that. Let's go to the results table and we'll just right click on there, go to legend. I really don't need 4 ranges. I'll drop down to 3 ranges. And I'll say that anything less than 70% is awful recovery. 70 to 85 is medium recovery. So 85, there we go, medium recovery. And 85 to 95, that's the good stuff. That's probably a better way. I could have used same frequency or same width or cluster, which was the default, but I've gone with this custom one. And because it's gold, let's just put it on that nice gold color, ready to rock and roll. So go back to here. Now we've got where the good recoveries are and the poor recoveries. Can also make it a bit more dramatic. We could use this magma, so you can see that the dark colors here are the high recoveries, and the yellow is the low recovery. If that's not intuitive for you, we could go to this divergent one where blue is low, grey is intermediate, and red is high. It's a pretty good way to look at it. Okay, rock and roll. So it definitely looks like we've got low recovery over in this side of the deposit. And I think I remember that we saw that this is where the sulfur was. Okay, let's have a little bit of look at the logs. So what I've got here is I've got strip logs, which shows me the depth from 0 to 153 meters in this particular hole. And these are the samples that I've got. And the scale only goes up to 1.2 grams per ton gold, but if I click on this one here, we can see that this sample here was actually 2.95 grams per ton gold. And you can't change the scales because it would just be annoying to have to do that. But what you can do is you can see from the color that it's beyond the clipping. Here we can see that the gold to silver grade does vary. It doesn't really tell us an awful lot. And the sulfur is all the way down here. I think from memory the stuff here in the west, the stuff in the west was the high sulfur, and that's what we're seeing here. Now we go to a point here in the east, we can see that it's got lower sulfur. Okay. This is a empty drill hole. Don't have any data on that. Another empty drill hole. Here we've got a drill hole with low sulfur, maybe a bit more oxidation here on top, and look, you get more copper up in this zone here. So this sample had quite low gold. Now if I wanted to choose another sample, I might choose this one here because you can see it's a little bit different, but it's only got 0.28 grams a ton gold from 55 to 80 meters on average. It's mainly silver, has a lot of silver, 1.5 grams a ton silver and very little gold. 81% silver and only 19% ratio on the gold. And this is interesting that the Blegs actually gave us a higher grade than what the that's just because the Blegs were less frequent, so we don't have continuous data for that. Alright, that's an interesting one. What about over here? Anything going on? Yeah, so again, you might, if I wanted to choose a sample from here, I could double click and just that interval there would get selected, and here I can see the grades of this one. If I liked it, I could right click and just say save sample. And then here in the metallurgical samples window, see from phase 2, I've got this new green sample, which was this new sample that I just saved over here. Interesting. I could also export these. I was going to go look in the drill core shack. I could take a bunch of printed logs with me. So it does look like we've got something going on with gold and silver. Why don't we plot this up? Why don't we have a little matrix plot to start with? We could say, okay, let's look in the assays. If I bring in the sulfur and I bring in the gold, well, let's just go, first of all, let's just go gold. Get rid of the sulfur and autocorrelate. Let's see what other elements are correlating to gold in the drilling. So it's just going through all the other elements and just checking to see what the relationships are, and then it ranks the one that has the best relationship. Now magnesium has the strongest relationship with gold, which doesn't tell me an awful lot as a metallurgist. Maybe geologists would have a field day with that one, but I don't see anything myself. I can also see that magnesium correlates quite well with aluminum here, mine's eye, and then gold with aluminum as well, 0.43. So yeah, I'm all positive, they're all red, so there's no negative correlations here. And not a lot to take home. So let's get rid of that and go straight to the meat and potatoes. As metallurgists, we're interested in gold recovery. Let's autocorrelate that. Well, this is more interesting. So we've got a strong negative correlation with sulfur, and actually a negative correlation with gold. But then we see that there is a positive correlation between gold and sulfur. Look at this little graph, and we know it exists, but we can actually go in a little bit more ourselves. We could just grab recovery. What we're going to do, we're going to look at assays, right? So we go get the gold and get the sulfur, and we can see that there's actually they're actually the high-grade gold seems to have a relationship with high-grade sulfur. And if I was to click on that one there, and I was to drag, for example, gold and sulfur, and in here, I can see, we've got that point there is BBS 009. And I wonder where it is in 3D, so I could just click on this here, and it'll take me out here, and look at that. I can see that it's out in the west, where we know that material was, the low recovery material was. So let's just go back to that analysis again. Maybe we could, if we've got sulfur and gold here, let's just drag the recovery and the cyanide consumption. Sure enough, low gold recovery. Where is it from in the log? So just click on that, and it's from here. So it's down the bottom. So 10% sulfur. Interesting stuff, eh? Very good. So let's have a little bit of a box plot. So say, for example, I wanted to know how different domains had this different recoveries. One way of looking at it would be to say, the level of oxidation might have a relationship there with the gold recovery, because sulfur is often inversely relationship to the oxide. But it's orange up here, so I have to click on this to consolidate. I didn't have all the data all lined up. And it looks, have I got my lookups? I haven't got my lookups. Right. Don't have my block open the lookup. So I've skipped a step in the features. I haven't taken the time to populate my samples with all my information from the drilling and the block model yet. So I'll just select all and apply. It's a small data set, so only take a few seconds. If you're doing a model with 1 million meters of drilling, which we've done, or 6 gigabytes of block model, it takes a bit longer than that. You might have to go get a cup of coffee. But when it's a small model like this, it just goes in 2 seconds. So it was good. All right, now let's go back. So now we've got, in lookups, I've got my block model, and I can group by the block model thing. Oh, sure, look at this. So, okay, these other zones do seem to have lower recovery than the oxide, but there's a good oxide and a poorer oxide, okay? Very interesting. If I hit Fisher grouping, there's not enough data, so we can't actually tell the difference between them according to Fisher. Okay. So, what are we going to do now? we could do a whole bunch more of this sort of statistics and stuff like that. We could put out a statistics table and say, okay, what's don't need all these different accounts for data. Get rid of those. We could say just to maybe count those and get rid of some of these percentiles. We don't need the 25th or the 75th. Alright, good enough. Now it fits on the screen. So we get all of our nice statistics for cyanide consumption and recovery. But I think we can do better. Why don't we use, for example, the different sulfur domains, and we'll just group by that. So now we've got low and medium sulfur. I wonder what that means. Show limits 0 to 2% sulfur and 2 to 16% sulfur. And here we can see that we've got very different cyanide consumptions and also very different gold recoveries in those different ones. I wonder, does that have anything to do with the phase of test work? Maybe we just used two different laboratories and they were the ones, different laboratories screwed us up. Possibly. Or what about, for example, stuff from the block model again? Maybe it's the this sort of lithology grouping that we had before there. But you can see most of the data is in these two, and these others aren't really. We didn't. Let's just go legend. Didn't we group these together? I guess we group those together, and then we group those together. I have no idea what they are, but this is a made-up case anyway, so don't hang me for it. Apply that, and if I wanted to move that up here, just to keep it organised and have, it's a nice contrasting colours there. If you wanted to have orange and blue, you can do that as well. Now, where were we? Now we can see that these have updated, and we've got our statistics table. I think what we're going to do, we're going to jump in. I mean, a lot of people might be saying, well, why don't you just go straight to targets? If you want to know what's going on with your recovery, just jump straight in. Well, yeah, you're right. But this is meant to be a tutorial. And, if the tutorial in Cancha only took 2 minutes, people would be underwhelmed with the software, so we make it look like you can do a lot more in the software in order to give it a higher value. But really, the stuff that used to take us a month, we can do in 2 hours now, which is neat. It also takes away a lot of the value that we're adding as humans, now that the software and the artificial intelligence does it for us. So, gold recovery, dragged into the target, got all the data loaded up. There's all the data from the block models. All the stuff in green is stuff that we didn't used to know about each sample. So the stuff in black, these are the hat assays, for example, and the easting and northing and RL of the different samples. But now we've got all this other information from all the other stuff, and we'll hit run. And literally 2 seconds later, we're out of job as metallurgists because the software did a better job than we could have at finding out that the gold recovery has got this equation to do with gold and sulfur grades. But we've still got jobs because we've got these things to look at as well. We could also divide it by low and medium sulfur domains, and this looks pretty interesting. But when you've got a wide bar like this in a domain, there's probably a function you can use in there. Got a wide range of gold recovery values for a single domain, so you wouldn't want to use a single value for that. So if we click on that, sure enough, it's given us a formula with sulfur. So if the right thing to do is a recovery for sulfur for the low grade and recovery by sulfur for the high grade, then the global model, which is another model with a greater sulfur is probably the right way to go. So don't divide it up into domains if you've got the same type of model and they're continuous for each individual domain. And that's why Cancha is recommending this one here. If we wanted to see the other models, we could click on it here. And if you wanted to have some crazy logarithmic model with an r squared of whatever, 0.79, so a lot of people will be, oh, this is very scientific. And look at all these fantastically complicated terms that we can use. That'll make us look very intelligent if we put this in a PowerPoint. Well, if you wanted to do that, you could. You could just copy and paste that into your PowerPoint. But I recommend you keep it as simple as possible. This BIC here is a Bayesian indicator condition that we used, one of the things that we used to minimize parsimony, minimize complexity, promote simplicity in the models. And that's what this one here is a winner. Okay, so we've got our targets, we've got our model. If we wanted to, we could put together reports, put together more assays and summary tables and 3D views and logs and things like that. But basically, we now know, that we have to talk to the geologists and get them to, map out the, where are we? Bring up the block model. And we put on the block model, we want to go back to the features here and bring up sulfur. So something going on here with sulfur. Need to talk to the geologists, get them to map that, get them to model it, find out why we've got high gold and high sulfur in those areas, and to minimize risk for recovery for the rest of it. But you can see that there is, look at a cross section, there are limited areas that are affected by this. Look at the top down, we could, so there is a limited amount of volume of rock that's got this high sulfur, and the bunch of the rest of it, like if we switch to gold, you can see that it's this other area in the east. Over here we've got a lot more gold, and so the bigger volume is where we've got better recovery. So that's good news. What we could do is we could take the target report and just make a note. We've got -4 times sulfur times gold plus 92. So we'll just copy that. And this is what the gold recovery is going to be equal to. So we just go to block model, right click and go create a feature, create a formula. This is going to be gold recovery modeled. And so we're going to be a bit careful because that's not sulfur like that, it's sulfur per. Gotta be careful. Try again. If you're not careful, the auto replace puts it at the end of the formula. You don't want to do that. AU ppm. All right, so we got some values. So the recovery, the gold recovery model is going to be 91.6s minus 4 times the sulfur minus 3.7 times the gold, and we'll apply that. And again, we want low recovery was, what did we say before? Up to 70% and then up to 85, I think we said. 85 and 85 to and above was going to be good recovery. So that's pretty good. Give it a nice sexy color. We'll make it a nice red one because it's important, and important things are painted red. Apply that, and now if if we consolidate with that one and we go to the 3D, we can look at our recovery in the block model. Cool bananas. So sure, we've got low recovery over here with its high sulfur, but look at that, most of it's good. And if we, for example, go to pivot and we say, what's the average gold recovery, and we do that by these domains like that, and do it by whatever that the thing is, what do you call it, the all category, or what do you call that, resource category, whatever, and we'll ungroup them just so we've got all the information. Hit the green button, so we can see here that got on average quite good recoveries, but certainly over in one area, there was this area here that had lower, and what we can just do is we can say, okay, well, let's put in density, because all the blocks are the same size. We can just put in density, and we'll just add the total of the density. We'll just do a percentage. Let's just do a percentage of the total. So what it's going to do is going to add up all the densities, because they're all the same volume, it doesn't matter. And then it'll give a percentage of the total. So we'll see, this is basically telling us the percentage of the tons. So here we've got, lower recovery in the C2, but it's only 12.5%. Better recovery over here. Well, I don't know what this code is, so let's just change this. We'll just put the sulfur. Let's just do that. We'll just group the sulfur. So sure, we've got lower recovery in the high sulfur, and higher recovery in the low sulfur, but look, 68% of the tons. Yeah. So we can group together these two. Let's just do that. Let's go to here. It's too many. It's too much. Let's just go high and low. Doesn't have to be more than that. Let's just go crazy. Let's just have two. We'll just go low sulfur, and we'll go high sulfur. It doesn't have to be any more complicated than that, does it? Apply. Go back to our pivot. Run that again. That's better. So 94% of our tons have got 88.5%. And what gold grade they've got. Here's me gold. So we've got, it's about the same grade in both. So we've got low recovery, 78% recovery for 6% of the tons, and 88.5% recovery for 94% of the tons with about the same grade. So when we were looking at it in 3D, when we didn't have any of this information, we would just be looking at it and say, geez, whoa, look at this. We got a whole bunch of samples here, they've got low recoveries. If we were to go to analysis and look at, put in the, you could say that about 30 or 35% of our samples had bad recovery. So people go, oh, geez, the problem with the deposit, affect evaluation, affect the project's viability moving forward. But then the good old geometallurgists come in using Cancha, and after doing a little bit of work, using information that we already had at hand, we're able to see that it's actually only 6% in a very controlled part of the mine, in a very limited area. And so we can add a lot of value to the project by having better classifying the risk according to these low recovery samples. So there's the example. Hopefully you can see the benefits of having an integrated workflow where you can transfer data between drilling and block models and drill holes and metallurgical samples. Something we didn't do, and maybe we should have, is that we didn't classify it. That would have been better. You see, I'm wrapping it up. I shouldn't be. I should be doing this. I should be showing you one last thing. Let's just go inside and outside of the pit. What's going on here? Oh no, okay, so that's in the drilling. Now we need to go to the lookups, so it gets complicated. There's the pit. So with drilling, we don't want the drilling one, we want the met sample one. But this block model. This block model, it's not going to work either. No, get rid of that. We need it to be block model. Do we have the Bonnie pit in the block model? No, we do not. Do we want it? Yes, we do. So we go to here, we got shell to block model. Let's put the Bonnie one on there and apply that. So now in the block model, we've got this new one called the Bonnie pit. And we've got in and out. Okay, so we've got out of pit and in pit. So the green is the in pit. And if we just go in here, we can see it. Well, that's probably not the best way to do it. Let's go to a section. Let's make a section straight through the middle there. Oh, we've already got sections here. Let's just go to the section. What do we call this? The west view. So on the west view, we can see that where's our bring up the Bonnie pit, and we can see that right where the pit was, that's where the colours have been assigned to the blocks. It's never perfect because if you look at the centroids of the blocks, they're never exactly where the pits hit on an angle. The shell hits on an angle. Mathematically, it's as good as you're going to get. And so now we've got the label inside and outside the pit. So we can see here that the stuff that's out of the pit, we're losing 27% of the mass outside the pit, and it's actually got pretty good recovery. So it's not, my hypothesis was that the stuff that we're losing outside the pit is low recovery. But now that we look at it, there is actually, if we look at the north view, so we know the low recovery is over here, and the pit's actually losing all this stuff here, which is high recovery. So important, that some of that low recovery stuff. Let's just bring up the recovery on that. So there is low recovery material. Let's turn off the higher recovery material. We can see that in the pit, sure enough, there is a whole bunch of low recovery material, but it tends to be down this wall, down at the bottom of the pit. All right, I think that's long enough. You've got the idea. So we've taken it right from, raw data input to having a populated block model with recoveries and thinking about options for mine planning using the current pit shape in about half an hour. So that's how effective Cancha is to your workflow. I hope you've enjoyed it, and good luck with your metallurgical modelling. See you next time.